The production of sugar is one of the main industries in Barbados. The sugarcane crop in Barbados usually commences in the month of February and lasts for approximately 3 to 4 months. This is the time when the cane is harvested. Harvesting is done manually and mechanically. In former years, men and women used a bill to cut the cane. The bill was gradually replaced when the cutlass, commonly called the Collins, was used. Because of the declining availability of manual labor, the sugar industry was forced to introduce mechanical harvesting. It was in the year 1969 that Dr. Colin Hudson invented the first mechanical harvester that was used in Barbados. This was known as the Carib Reaping Aid, which cut and laid the cane on the ground. The cane was then cleaned and loaded. Since then, mechanical harvesting has gone a step further. Today's machines now cut and load the cane at the same time, a process known as combined harvesting. One model used in Barbados is known as an Ostoft 7700. It can cut and load between 250 and 300 tons of cane per day and costs approximately $400,000. In a small sugar-producing country like Barbados, this machine can cut and load 12,000 tons of cane per year. In larger sugar-producing countries, it can cut and load over 30,000 tons. Mechanical harvesting is done mainly in the south of Barbados and manual harvesting in the north or wherever there is hilly terrain. The reaped cane is transported to the factories by lorries, tractor trailers, and large, long cane bins. The lorries and tractors go into the cane fields where they are mechanically loaded. They carry between 5 and 6 tons of cane. The large, long cane bins or carts carry over 20 tons of chopped canes. They do not go into the fields, but are loaded from tractor trailer at a transloading station. The current one in use is the former sugar factory called Carrington in St. Philip. At present, this is the only sugarcane transloading station in Barbados. On arrival at the factory, the cane is first weighed at the weigh bridge or scale beam. The weigh bridge is computerized and can weigh up to 40 tons. For example, it can accommodate the tractor trailer with 2 loaded cane carts or a large, long sugar bin. It has replaced the scale beam, an older form of weighing. The scale beam could weigh 15 tons only and could accommodate a single lorry or tractor trailer cart. Therefore, the weigh bridge can be seen as one of the many forms of technological advances in the sugar industry. At the factory, the cane is sampled to assess its quality. It is on this quality assessment that the cane suppliers are paid. The sampling station is all computerized. The cane carrier transports the canes in the factory. The factory operation can be divided into 2 parts. The first part is milling. This is performed in what is called the mill house, where the juice is squeezed from the canes. Secondly, the squeezed juice is boiled into sugar in the boiling house. The cane is first prepared for milling by large rotating knives which cut them into small pieces. This knifed cane is further reduced to finer particles by cane shredders. The prepared cane is then fed to the mills, where it is squeezed between heavy rollers to extract the juice. The milling plant usually consist of 4 or 5 mills. Each mill comprises 3 rollers. Before the crushed cane goes to the last mill, water is then added to the blanket of cane at that point, and to ensure that as much as possible of the juice is squeezed out. The fibrous material from the last mill is called bagasse, sometimes referred to also as megasse. The bagasse is used for fuel at the factory by burning in furnaces to generate steam in the boiler. The steam is the lifeblood of the factory, as it is used for heating, providing motor power, and generating electricity. Generally, the juice from the first 2 mills is combined and called mixed juice. The mixed juice is transferred to the boiling house for processing into crystal sugar. The juice from the other 2 mills is recycled to wash out some of the remaining juice before the cane blanket is squeezed again. The mixture is then heated by steam in juice heaters. In the boiling house, the first process that the mixed juice is subjected to is clarification. Clarification removes as much as possible of the impurities in the juice. It is achieved by adding calcium hydroxide, commonly known as white lime. The heated juice is then pumped to the clarifier, where the impurities settle to the bottom as mud. The clear juice is called clarified juice or crack liquor. The settings, or mud, are then filtered to remove residual juice. This process is carried out at the filtration station. The wash-ins, or filtrates, are returned to the juice tank, while the filter cake, which is scraped from the filter, is a byproduct used to make compost. Compost is made from a mixture of filter cake, bagasse, and furnace ash. This is allowed to decompose and turned several times until it is suitable as a fertilizer. The clear or clarified juice, which is of light density, is now concentrated to a thick syrup by boiling off the water it contains in the evaporator. The syrup is then pumped from the evaporator to storage tanks, where it is held until needed by the vacuum pans. At the vacuum pan station, the syrup is then further concentrated by boiling off more water until sugar crystallizes out. Tiny crystals of sugar are drawn in as seed crystals, then allowed to grow to the desired size by feeding on additional syrup while water continues to evaporate. All the sugar in the syrup cannot be removed in one crystallization step. Hence, the sugar boiling process is done in a series of steps to give more than one crop of crystals. The molasses coming from the first crop of crystals is now boiled further to produce a second crop of crystals. The molasses from that crop of crystals is again boiled to a third crop. Crystals from that crop are separated from the mother liquor, which is called final molasses. Molasses is used in the manufacture of rum and animal feed. The sugar crystals are separated from the mother liquor by spinning in centrifugals. The sugar crystals are then transported by elevators and conveyor belts to storage at the factory until they are bagged